Our next topic is physical game analysis, and we will have Mr. Marko Haverinen here, Director of Testing Lab of Varala High Performance Training Center. So if I can have Marko up here joining me, and that will be the next topic of the day. Hello Marko and welcome. Physical game analysis, the floor is yours.
Thank you. Thank you very much, Eerikilä High Performance Training Center, and also, of course, Floorball Federation for the invitation. I appreciate it. So, we're going to talk about physical game analysis in floorball. This is part of the bigger work we have been doing with the Finnish Floorball Federation. We have done a larger work concerning physical needs analysis in floorball. And in that work, we are going to talk about first the developmental stage of floorball, how the trends of physical qualities have changed in Finnish floorball national team, what are the interactions between physical qualities and key performance indicators. And we also interviewed the floorball coaching network, what is their view of physical demands in floorball. And we are going to talk about, in this larger work, about the physical game analysis, of course, but also the physical qualities of players and how they interact and how they connect also to the training load of the whole season. In this presentation, we are going to concentrate on the physical game analysis. And this has been done in cooperation with the Eerikilä High Performance Training Center and Finnish Floorball Association, as well as Varala High Performance Training Center and Tampere Sports Academy. Yes. And University of Jyväskylä, Polar, Finnish High Performance Institute, KIHU, and of course F-League, which is the highest elite level of Finnish floorball series. And about this presentation, this is actually a master's thesis of Jiri Kirsilä, so if I say something funny, you can blame Jiri for this. No, exactly, we are doing great cooperation with Jiri and also the expert here in Eerikilä, Elisa Hakamäki, who has also been a part of this work. But as I said, Jiri is doing his master's thesis about this study in University of Jyväskylä. We are going to go through shortly the introduction, methods, results, and discussion. So basic scientific research, sort of say. First, introduction. So the Finnish Floorball Association, there was a necessity to update the physical needs analysis in floorball. As you know, floorball has changed quite a lot in the past couple of decades, and maybe the previous physical needs analysis have been done also in a couple of decades ago, so there's a necessity to update the physical needs analysis. We're going to measure things. This is nice how the previous presentation combines to this one, because we are going towards the knowledge-based leading in Finnish Floorball Association, as well as evidence-based coaching in floorball, and we're trying to figure out, is the floorball game the way we think it is? So we're measuring things and we are looking at the facts and data, how we see the floorball game in 3 different levels. So the purpose of this study was to investigate the differences and connections between external and internal load in competitive floorball match between U18, U21 and men in elite level, period by period. And first research question we had was that does the external and internal load differ between the levels of play? So is there a difference between U18, U21 and men in these measures of external and internal load? And the next one, are there differences in external and internal load between periods, period 1, 2, and 3 in these levels? And finally, what is the relationship between internal load and external load? We will go through what exactly the external and internal load means. Well, shortly about the methods we used. We measured U18, U21, and men in the highest level of play, Finnish Championships Series. And we had 8 participants in all of these levels. And of course, meaning that the defenders, wingers, and centers, there were not so many that we could actually measure the differences between playing positions. So we only measured the differences between those levels, U18, U21, and men. And in U18, we measured 9 games, U21, 6, and in men, 12 games altogether. We used Polar Team Pro system, so measuring external load. Of course, Polar Team Pro is GPS-based system, but indoors we use the IMU sensor with accelerometer, gyroscope, and magnetometer to measure the movement of the players. And also, this system measures the internal load, so heart rate basically was used for that. And data collection, we measured the whole game, but we paused the recording after each period. So only the period 1, 2, and 3 were measured. And we get quite a lot of data for these 3 levels. We took the whole game, of course, with summing up those periods, but we also look at the period 1, 2, and 3 separately. And about the variables, external load and internal load variables. Here you can see the external load variables. In the upper part of this slide, there's a velocity zones used in floorball. So from 1 to 5, 1 being very slow speed running, from 3 to 10 kilometers per hour. Number 2, slow speed running, 10 to 14. 3, moderate speed running, 14 to 18. 4, high speed running, 18 to 25. And finally, very high speed running area number 5 is over 22 kilometers per hour. So how many distance in meters the players covered in these speed areas. And also we measured the total distance in meters, average distance, describing more of the intensity, how many meters the player traveled during the game per minute he played, maximal speed, average speed, and also sprints. Number of sprints, meaning that how many sprints were there in a period 1, 2, 3, and altogether in a game. And the limit was 22 kilometers per hour. And then also the external load variables include accelerations and decelerations. Accelerations in 4 different categories, and also decelerations in a low, intermediate, high, and maximal accelerations and decelerations. You can see the thresholds over there from 0.5 to 1 was the low acceleration or deceleration, intermediate 1 to 2, high 2 to 3, and maximal acceleration and deceleration was 3 meters per second square. So how many visits in those areas? And about the internal load, we used heart rate, of course, and in Polar system there are 5 different categories in Polar heart rate zone areas. First, very light, 50 to 60% of heart rate maximum. Light 60 to 70, moderate 70 to 80, hard 80 to 90, and finally 90 to 100% of heart rate maximum was the area number 5. And of course, minimum, average, and maximum heart rates were recorded, and calories also estimated through the system. So those are the variables we collected. Quite important thing is the exclusion of the games. So the criteria in that was developed in 2 stages. Stage number 1, there were a group of experts from Finnish Floorball Federation that choose those games. They have to be competitive games with high demand of floorball. And basically the games were in the last part of the regular season, so not in the first half of the season, but mainly in the later part of the regular season, meaning that there's a more competitiveness in those games, probably. And important thing also was that the goal difference between teams was 3 or less when coming to the third period. So it was a tight game, it was a high competitive level, and at the end of the regular season. And after that, we did another filtering individually, so the players has to play the whole game, and he has to also play at least 4 shifts in each period. So that was the main thing. Of course, we didn't take overtime or shootouts. We only take the regular playing time for those players. And now the main thing, results. First we're going to look at the differences in external and internal load between the levels of play. So whole game in U18, U21 and men. What's the difference? Actually, there were not so many statistically significant differences. Calorie consumption was the only one. If we take that p-value 0.05 is the statistically significant limit. So as you can see, the men consumed more estimated energy during the whole game compared to U21 and U18. We can also check the statistical p-value of 0.05 to 0.1, which is not exactly significant, but it might be important when concerning practical applications and the actual coaching. So in that sense, there were another weak differences in heart rate zone 4. The men spent more time in this high-intensity heart rate zone compared to U21 and U18. And also the distance covered in speed zone 5. So the high-intensity speed in speed zone 5 was higher in men compared to U18 and U21. So it seems that the physical demands of high competitive level is higher in men compared to U18 and U21, both intensity and volume. So next one, if we look at the period by period, so on the left you can see there's a U18, U21 and men in period 1, in the middle period 2, and on the right side period 3. And if we look at the period 1, what kind of differences are there where they're not so logical and there are not so many statistical differences? Maybe the one important notice is that the maximal speed and also the distance in zone 5, even though they are not statistically significantly different, you can see that men covered more distance in speed area, high intensity speed area number 5 compared to U21 and U18 in period 1. Period 2, same trend continues. Men and U21 had higher maximal speed compared to U18. This was the same in period 1 also. And the same trend continues. Men covered more distance in the high intensity speed running in period 2 compared to U21 and U18. In period 3, there seems to be additional differences. The difference is maximal speed continues. Men achieve more maximal speed compared to U18 and U21, and distance in high-intensity speed running area is higher compared to U21 and U18. But also in distance in speed zone 4 is also higher. So it seems that men can produce higher maximal velocities compared to U18 and U21. And when it comes to period 1, period 2, and period 3, it pronounces. So it seems that men travel more distances in high-intensity areas already in period 1, but it is more pronounced in period 2 and period 3, especially in period 3. Next one, if we look at the periods in that level of play, so within that certain level of play, we only look at on the left side U18, period 1, 2, and 3, in the middle U21, period 1, 2, and 3, and finally on the right side men, period 1, 2, and 3. What's the difference within the level of play? Well, U18, quite interesting exactly, is this that the average heart rate actually decreases from period 1 to period 2 and 3. And at the same time, we can see that the distance covered in the low-intensity heart rate zones and low-intensity acceleration, deceleration zones increases. So this is quite interesting. U18, their internal load decreases, and it is connected to the increasing intensity in low-intensity zones. So this might be something to look at more when we look at the younger players. At least in this study, they were not able to generate high intensity towards the end of the game, and their internal load decreased also. Looking at U21, it's more or less the same. It's a bit more towards the men, but the basic thing is the same concerning that the low intensity increases towards the end of the game. But you can see that in speed zone area 5, there's an increasement. So it's the same but different. The low intensity increases towards the end of the game, but also the high intensity increases towards the period number 3. But when we look at the men, it's a bit different, to be exact. You can see that the time spent in the high-intensity heart rate zones increases. The time spent also in the high-intensity speed areas increases. Well, also the low-intensity efforts in accelerations and decelerations increases. But it's a bit different compared to U21 and U18. The low-intensity efforts increase as in U18, but the most important difference is that the time spent in the high-intensity heart rate zones and speed zones increases for men. And it can be seen also not only the intensity, but also the volume. Also the volume of total distance covered increases towards the end of the game. In the first period, it was 1,300 meters, second period 1,400 meters, and final period almost 1,600 meters. So the total volume increases in men towards the end of the game, and also the low and high intensity efforts increase. So it seems to be a bit different compared to U18. Then, looking about the high and maximal accelerations and decelerations, here you can see that, well, this gray column is U18, this light gray is U21, and this black column is men. You can see that for men there seems to be high amount of high and maximal accelerations compared to U18 and U21, even though this is not statistically significantly different. But what was statistically significantly different was the amount of high accelerations compared to high decelerations. So in the middle, you can see that the amount of maximal decelerations is much more higher compared to maximal accelerations. So this is quite important to notice that the floorball might be more of a deceleration sport involving eccentric muscle contractions compared to acceleration sport. We can discuss this more in the conclusions. But that was main finding here. And finally, the relationship between internal and external load. This is the correlation matrix between those external and internal variables. If we look at the correlations between external load, so the movement compared to the internal load, heart rate variables, here you can see are highlighted the correlations that occurred at least in 2 levels. So U18, U21 men, at least 2 levels of correlations occurred in these cases. And what was the most interesting finding, it's quite natural, is that the heart rate average and heart rate maximum was well correlated with the external load of, for example, maximal speed, sprints, and speed in distance covered in speed areas 4 and 5. So, meaning that the more you take sprints with higher velocity, the more you run in high speed areas, the higher your maximum heart rate and average heart rate is. So, no big surprise, but nice to see that it happens. Then, if you look at the correlation matrix with only one correlation, so only U18 or 21 or men, then we can see that this is quite interesting finding that in men there seems to be higher correlation between internal and external load compared to U18 and U21 when it comes to spending time in the high-intensity heart rate zones. So for men, the more they spend time in high-intensity heart rate zone number 3 and 4, the more they also covered for total distance during the play, and the average speed was higher, and also the number of deceleration and accelerations were higher. And this was not so pronounced in U18 or U21. So at least for men, external and internal load with high intensity and high volume seems to be correlated quite nicely. Here you can see exactly how many correlations there were. For U21 and men, there were almost 60 significantly correlated between internal and external load, and for U18 it was only 16 pieces. So finally, discussion. I will go through the main conclusions for this study. If we look at the differences between the total game, between the levels of play, it seems that the volume was higher for men compared to U18 and 21 when it comes to energy consumption. So higher volume, this might describe the higher volume men achieved during the whole game. But also intensity, seems that the men achieved higher intensity in heart rate zones and also the speed zones compared to the U18 and U21. So meaning that the demand of the play when concerning physical qualities is higher for men compared to those U21 and U18 groups. Not a big surprise, as I said. When it comes to the periodic differences, there were not so logical differences, but the most important thing was that men achieved higher maximum velocities and higher amount of work in the high-intensity speed area in period 1, period 2, but especially in period 3. So it seems that the physical demands of the play are higher in men especially towards the end of the game. And finally, when we look at the differences between period 1, 2, and 3 within the level of play, there seems to be more correlations, statistical differences. And it seems that for men, the volume increases towards the end of the game, and also the low and high intensity efforts increase towards the end of the game. And this was not seen in U18 or U21. On the contrary, in U18, the intensity shifted more towards the low intensity areas, and also the internal load heart rate dropped down towards the end of the game. So there's a big difference what we saw in U18 and men. An interesting comparison, in Sweden, Wedin and Henriksson have studied that floorball game involving interval type of intensity. It induces muscle damage in heart muscle, and if we look at this study, it might be more provoked in men than U18 at least. Then, this is quite important notice that it seems that the amount of maximal decelerations was statistically significantly higher compared to maximal accelerations. So is it so that floorball as a team sport is more of a deceleration sport involving eccentric muscle actions compared to the acceleration-based concentric actions? And what it means to training, that's the most important thing. Well, previously, Kati Pasanen et al. Colleagues in 2008 have studied, I'm sure you're familiar with this study, they have studied that implementing neuromuscular training in warm-up decreases injury risk in floorball. So I think that this current study adds value to this previous study in a way that there seems to be high amount of eccentric muscle actions in floorball game, and you have to train those. You have to train to be able to produce those eccentric forces during the game. Well, high intensity as well as low intensity external and internal load variables are interconnected, especially in men, as we saw. And why is it not so in U18? Is it that in U18 the level of physical, technical or tactical qualities are not so high level that they can produce high external workloads during the game? This is something that I think we need to discuss. But in men, it seems that there's a clear emphasis of high amount of correlations between high intensity as well as low intensity, but especially high intensity and volume related variables connected to internal load. For example, we saw that the time spent in heart rate zones 3 and 4 was correlated for the amount of work or volume done, and also the high intensity actions done in a game. Of course, we have to think about causality. What is the chicken and what is the egg? Is it so that by improving those speed, strength, and power characteristics, you can improve your neuromuscular performance and ability to produce high-intensity actions in a game, and it reflects the physiological response, so higher internal load? Or is it other way around, that by improving aerobic and anaerobic endurance, you can improve your cardiopulmonary performance and you are able to maintain those high-intensity actions during the game, and this reflects to higher intensity external load? Which way is it? Of course, always the correlations are both ways, and it seems that the external and internal load are interconnected, so you have to improve those physical qualities in a vast major of that spectrum. And also it recognizes the individual differences. Some athletes might be more speed type of athletes. They might have to improve those endurance capacities, and some athletes are more endurance type athletes, and maybe those athletes have to improve those speed and strength capabilities. Well, final slide, take-home message or practical applications. Not a big surprise, but it seems that you have to improve physical qualities, and I think that by improving physical qualities progressively from youth to adulthood, you can improve also the potential to improve the game performance itself, and you can, in that way, overcome the increasing physical demands when it comes to elite floorball game. You have to improve both strength, speed, and power, but also the aerobic and anaerobic endurance characteristics. And this is quite important. Notice that we saw that the decelerations were much higher compared to maximum accelerations. So you should address this in the training. You should improve your eccentric force application by doing plyometric training, deceleration skills, also body control and movement skills, change of direction, speed and technique, and way of improving the eccentric strength overall. So this is quite important notice, I think, practical application from this study. And the other one is that you should train the way you play. We saw that in men, the amount of work, volume increases to the end of the game. Also, the low and high intensity efforts increase to the end of the game. So, you should design those floorball sessions to imitate these physical demands of floorball game by increasing the duration of high intensity efforts towards the end of the training session. What it exactly means is that, well, in the larger work, we're going to address this, how to design those floorball sessions, but from this study it seems important to notice that you should maybe start from speed or lactic speed endurance towards the lactic speed endurance towards the end of the floorball training session. So you can shift from the neuromuscular system to the lactic energy pathway and all the way to the aerobic energy metabolism pathway towards the end of the training session. All right, bunch of references for those who are interested, and thank you, and thanks for our partners as well.
Thank you. We actually have a question from Australia, from P. He is asking that, is there any data about players who play both in the youth teams and in the men's level? And if so, do they sort of play with higher intensity in the men's game, or do they perform at the same level?
That's quite an interesting question. We did have players who played, at least in the U21 and men, but we didn't exactly look at the differences. That might be one interesting aspect to look at. Yeah.
I know you guys love guessing.
Yeah.
We concentrated on data, but any educated guesses there?
Yeah, well, I think that the players usually, they reach the end of the level of the game. So if the game invites you to produce more power and produce more speed in high-intensity training efforts, if the player is able, if his physical qualities is possible to use those physical qualities in a men's level, then I think the player might be able to reach to the level of the game.
It sort of raise to the level
of
the intensity. Very interesting. Thank you very much, Marko. Thanks. We move on.